Okay, hi Julia, and I apologize. We didn't get the going over the worksheet. Feel free to stop by on your own and do this. This is the very beginning of the notes for today. These are the two formulas we've had so far. Formula for a circle, formula for an ellipse. The only real difference with an ellipse, the top of the ellipse formula is identical to the circle formula. But instead, the x stuff is divided by horizontal radius squared. The y stuff is divided by vertical radius squared, and the answer is equal to 1. For an example, how do you tell them apart if they give you a messy problem? Here's an example of something that's a circle. X squared plus y squared is equal to 16. That's guaranteed to be a circle. You can throw other stuff in there too. Actually, x squared plus y squared plus 3y plus 2x minus 6 is equal to 0. I'm going to make it a mess. That's still a circle. And let me see why. Why is that a circle? Go.
Because it matches all of them. It has the same coefficients, they're all being added, or like the same sign.
Right. This is plus and this is plus.
And they're both squared.
And they're both squared, and they both have the same coefficient. That has to be a circle. Correct. No matter what the other messy stuff goes, it's got to be a circle. This is also a circle. This throws people. Negative 3x squared minus 3y squared plus 4y minus 7x plus 13 equals 0. All right, I would not want to graph this thing. It's a disaster. But how do you know it's a circle?
The x squared and y squared have the same coefficient.
Okay, they have the same coefficient. What else?
Do they have the same sign too?
Same sign. They're both minus minus. And then one last thing. They're both squared. Correct. If x and y are both squared, at least somewhere, if they have the same sign, plus plus and minus minus, and if they have the same coefficient, 3 and 3, that has to be a circle. Okay? If it exists at all, it's going to be a circle. Now, what does an ellipse look like? Here's a quick example. 2x squared plus 4y squared plus 3y plus 2x minus 1 equals 0. How do I know that's an ellipse? Do the situation.
It has different coefficients.
Right. They're both squared, which is good. They're both plus plus, but they have different coefficients, which means they're going to have different sizes in the x direction and in the y direction. That will make an ellipse. Does that make sense? Everybody feeling okay on that? Alrighty. Let me show you a few variations on this. The book is not going to show this to you yet. It should. I will. This is what's called general conic form. I might even have given this to you once. It looks like this. Capital A, x squared. Maybe I didn't. Capital B, xy. Plus capital C, y squared. Plus capital dx, plus capital EY, plus F equals 0. Every single conic on Earth can be put in that form. If you'll notice, this is in that form. There are a couple of zeros in there. This is a quick diagram there. This is 2x squared plus 0xy, because there aren't any xy's in there, plus 4y squared plus 2x plus 3y plus negative 1 equals 0. That is provably a conic. So it's got to be one of the four forms, the shapes that we're going to be studying. Circle, ellipse. Let me know the other two names. Circle, ellipse, hyperbola, and parabola. Next. We don't know what those are yet. Well, we know what a parabola is. But there's some exciting stuff about parabolas that we did not know yet. But this, anything that's in this form, is a conic, is a slice of a double cone. It'll be one of the four shapes. make sense, Mark? Now, basically, it is a circle if A is equal to C. If A and C are not equal to 0. So if you know the conic form, the general conic form, all you have to know is if A and C have the exact same coefficient, that'll handle both plus or both minus. And as long as they're not 0, if that happens, then it might be a line. Then you're looking at a circle. How for an ellipse? If A is not equal to C, and A and C have the same sign, not equal to 0. That'll be an ellipse. Basically, the coefficients of x squared and y squared make all the difference in the world as to what shape you're talking about. I will tell you this. Let's see if you can, oops. Let's see if this marker is a little more fresh. This section right here, ax squared plus bxy plus cy squared, this determines the shape. Dx plus ey plus f will not change the shape. This determines the position. The d, e, and f will move the thing up, down, left, right. A, b, and c will make it a circle, and it'll make it bigger or small. Okay? We're not going to hammer this general conic form for a while. It's going to be near the end of the chapter. I wanted you to see it just so you knew. It's not all that scary once you realize we've been playing with it for a while. The only thing we really need to worry about this right now is we might need to complete the square. If they give you a mess, and they say, here, go ahead and graph this, then we're going to have to complete the square. Speaking of which, we have number 1, number 2, number 3, and number 4. I am going to start you off with a problem of your choice from 1 or 2. Take it, Chris.
Yeah, 1 was screwed up one.
I thought we didn't have to do that.
Number 1, let me double check
Is
here.
that the decimals or whatever?
Oh, yeah. Well, that was, oh, merciful heaven. You know, I had actually blocked that out. Okay.
I started doing it, and then they were like, oh yeah, we didn't have to do that.
Yeah, we're getting, there are horrible radicals in the, like the horizontal radius and things like that. It does work. It's just, number 2 does work. Number 2 is nice. Hopefully you got that. Number 3 and 4 are the doing the detective work. Those should work well as well. No pun intended. Number 5 and number 6 should work relatively well, although they might be a little tricky. Would anybody like to pick 5 or 6 to work on? 6. Should we do that? And believe it or not, when you get these really gross looking foci, it's actually good news for you. I'll have to explain that in a minute. The foci are 7, I'm going to call them F1 and F2. Marker's full. 7 plus 2 radical 13. Comma something. 9. And the other one is 7 minus 2 radical 13 and a 9. Believe it or not, that actually tells you a lot. The fact that they have the radicals in there tells you a lot. And the covertices, what does that mean? That's the book's nickname for something. What are covertices? Yeah. Minor vertices. Covertices and minor vertices mean the same thing. In other words, the minor vertices 7, 21, 7, -3. Can anybody tell me what code letters those are? The vertices, it's B something. Which ones? Yeah, B3 and B4, correct. It doesn't matter which one is which, as long as you can include the goal. Okay? What would you suggest doing? They want us to find the equation in standard form of an ellipse. Not general form, standard form, with the x minus h times the squared stuff. Where do you start? Ideas? What would you do? Suppose this is on a test. You have to do something, so where do you start? Yeah.
Find something.
Graph it, definitely. Now, you're gonna need kind of a big graph. That's okay. You don't have to make every single dash, I don't. I'm gonna graph the B3 and B4, because they're easier. I'm gonna call this 7, we call this 21. 7, -3. This is B3, B4. That tells us several things. Can anybody deduce anything just based on the two things I did earlier? Yeah.
Well, we can average them out.
Right, and find the what? Find the center, correct. The center is the average of the two foci. So it's, or actually the two vertices. Either way.
Yeah.
Does everybody, actually it's even easier on here. Did we see the center? 7 plus something and 7 minus something, guess where the middle of it is? Don't work too hard. 7. 7 plus 5 and 7 minus 5, it's got to be in between a 7. So this is 7, 9 is the center. But pretend you didn't see that. This is going to average 7 plus 7 over 2, which is one of the dumbest averaging problems we've done in a while. Halfway between 7 and 7 is 7. And then the other one is 21 plus -3 over 2. What is that?
18.
Yeah, it's 18 over 2, which is 9. So the center is 7, 9. I'm going to mark that. Okay. That tells us something else, too. What? Actually, you can figure out about 3 extra things just based on that alone. Just facts about our ellipse. Can you tell me anything at all about the ellipse that we haven't covered yet? Use your detective skills. Yeah.
Did you find the vertical radius?
You can find the vertical radius. How big is it? 12. The vertical radius is 12. And it's a little harder to see, but you should be able to tell me something else as well. You cannot give me the horizontal radius. I didn't give me any clues for that yet. But there's something, yeah. You can find the focal move. We'll do that in a minute. Just based on this, and that's definitely right. There's something else about this. Here's a hint. The fact that they used V3 and V4. What does that tell you? And not V1, V2.
Well, this one guy gonna go left, right.
Yeah, the posts are going to go left, right.
This is the minor radius.
This is the minor radius. What letter?
B.
It's B. We now know that's the minor radius because they used V3 and V4. That's the minor direction. The major direction, in other words, this ellipse is going to be wider than it is tall. Now, so let me just get a running total of this thing. By the way, all we wanted was the equation. We don't need to analyze everything. Muscle. If you want to, go ahead, finding the focal move. We've got the focal move. Anybody see what the focal move is? It's kind of obvious on this one.
2 radical 13.
It's 2 radical 13. The focal move is 2 radical 13. Anybody see why? Because that's how far from 7 you move. It's 7 plus 2 radical 13 and 7 minus 2 radical 13. Quick question. You know the vertices, like the farthest vertices? Are they going to be further out than the foci or not as far out? See if you can picture the ellipse in your mind. You know, yeah,
farther.
they're going to be farther. Because the foci are always inside the ellipse. The vertices are as far as you can go. So, I've got the focal move, and I've got the minor, this is vertical, as being 12. Does anybody see something that you could do, or detectives in mathematics, by which you could find the other radius, which is the only thing we need? Yeah.
Well, you can use the equation for the focal move.
Yeah, what is that again?
C equals square root of a squared minus b squared.
Good. Plug in what you have.
So 2 radical 13 equals a squared minus 12 squared.
Yes, a squared minus 12 squared, which in this case is what?
Oh, 144.
144. So we're still with me. Take over Polly. How do you get a by itself? I'm sorry. Square it first, yeah, as long as you do it to both sides. This one's a little tricky. 2 radical 13 times 2 radical 13. You can square them individually. 4 times. There's 2 ways to write this. One is easy, one's hard. Radical 13 squared. The hard way is to do radical 169, which is true. Then what happens with square and square root? Bingo. Guess what you get? 13. Right. Radical 13 squared is just 13. What's 4 times 13? Yeah, 52. Okay, so 52 is equal to, and these cancel, a squared minus 144. Keep going. Add 144. Okay. So a squared is equal to, how many? 196. Does that look familiar to anybody?
Oh, yeah.
What is it?
This one, 14
It's
squared.
14 squared, so a is 14. You got lucky, it's a perfect square. By the way, you can punch that on the calculator if you start. It's nice if you memorize the perfect squares up to 13 at least. If you have 14, that's handy, and the beyond will be nice. We have just found what? What is that? Yeah. Horizontal radius. The major radius, which is the horizontal radius, we're going to go 14 spaces. And interestingly enough, I don't even need to know where B1 and B2 are. As long as I know this is 14 and this is 12, and as long as I know the center, which I do, finish the problem for me, somebody. Give me the equation. Darn it, I erased it. The x minus h parentheses squared, blah, blah. Go.
X minus 2 squared over
X minus,
oh, sorry, I'm looking at the wrong one.
okay.
X minus 7
7
squared
squared, good.
over 14 squared.
Good. 14 squared is the horizontal.
Plus y minus 9 squared
Good.
over 12 squared equals 1.
Squared equals 1. And then simplify. The top, so you keep it the same. So x minus 7 squared over what? I mean, 14 squared? It's actually on the board. 196, good. Plus y minus 9 parentheses squared over 144 equals 1. There you go.
So you always want it in the floating square.
I do. Yeah, do not expand the top though, that would be obnoxious, yeah. I've had people do that. This is x squared minus 14x plus 49. I said, well, bravo, but oh my goodness, no. You need not do that. Make sense? The rest of the hour is yours. Go ahead and attack. Comments, do you have any questions? Otherwise, enjoy. Let's see. How many minutes of people are reading now? Wow, thank you. You just saved Julia from about 20 minutes of staring at a blank board. Sorry, Julia. Okay, see y'all.